In this lecture, I am going to share the meaning of tangent law in magnetism. What is the meaning of tangent law? Suppose I have a magnet of some length with the north pole and south pole. In this situation, if I apply external magnetic field, suppose it is B1 in this direction, then a force will act on south pole as well as on north pole. Because this magnetic line of force is representing external magnetic field B1, it means source of this B1 will have north pole on left hand side and south pole on right hand side, because magnetic lines always move from north towards south. Because north is here, it will attract this south pole with some force. Similarly, north will be repelled towards this direction, and force on both the poles will be same. Let me call it F1 vector. And this couple of forces will tend to rotate the magnet in clockwise direction. Now let me apply another magnetic field in vertical direction. Suppose this magnetic field is B2. As discussed earlier, this external magnetic field B2 will also exert forces on two poles of the magnet. The south pole will be experiencing force in this direction. Let me call this F2 vector. And north pole will experience in this direction, again same force. Same force will act in opposite directions. And this couple of forces F2 will also tend to rotate the magnet in anti-clockwise direction. B1 and B2 are perpendicular to each other. Suppose this angle is theta, means length of the dipole is making angle theta with magnetic field B2. If this angle is theta, if I complete a triangle here, then this angle will also be equal to theta. Let me call this point as P. Let me suppose M is pole strength of the magnet. Means each pole, north and south, has strength M. Now, what is the force acting on poles? Force due to magnetic field B1. It will exert a force F1 that can be written equal to M multiplied with B1 according to definition of pole strength. Similarly, force due to external field B2, that can be written equal to F2 is equal to MB2. Let me call it equation number 1 and it equation number 2. Torque due to couple of forces having magnitude F1. Let me denote it by tau 1. Now this torque is defined as magnitude of force multiplied with arm of the couple, because these two forces are anti-parallel. So this distance, vertical distance between line of force is called arm of the couple, and in this case this couple is arm is N to P. So I can write arm of couple as N into NP distance. Now from this triangle SNP, I can find value of NP, Np can be written is equal to Sn cos theta. Let me call it equation number 3. Because from this triangle, I can write cos theta is equal to Np divided by Sn. Just mathematics. Similarly, torque due to couple of forces F2, F2, torque can be calculated at tau 2 equal to magnitude of force multiplied with arm of the couple. In this case, arm of the couple is SP. It is the vertical distance between line of action of two forces. And SP can be replaced by, as done earlier, Sn sine theta. Because from this triangle, I can write sine theta is equal to Sp divided by Sn. Let me call it equation number 4. So tau 1 tends to rotate the magnet in clockwise direction, and tau 2 tends to rotate the magnet in anti-clockwise direction. At equilibrium, both tau 1 and tau 2 become equal. At equilibrium, where magnet gets stabilized, both the torques become equal in magnitude and opposite direction, and the magnet stops moving. From previous questions, if I equalize the values of tau 1 and tau 2, I can write mb1 Sn cos theta equal to mb2 Sn sin theta. After simplifying, I can write value of tan theta equal to b1 over b2. What is the meaning of this relation? Means at equilibrium, the length of the magnet will make an angle theta with magnetic field B2 such that tan of that angle tan theta will be equal to magnitude of B1 to magnitude of B2. This relation is nothing but tangent law in magnetism. Now let me repeat the definition of this law. This law can be stated as: if a magnet is under the influence of two mutually perpendicular magnetic fields, then the magnet will get stabilized, means it will be in equilibrium, making an angle theta with magnetic field B2 such that tan of that angle is equal to ratio of B1 to B2. That's all.